Yeah, so good evening, sir. We are here to do our lab assessment number 6. So right now I'll share the screen. So we have been done our lab 6 on the title of Ohm's law using multisim simulation. So I'm Yamuna and my partner is Tommy. Okay, so the objective of this lab is to investigate the relationship between voltage, current intensity and resistance. So we have to set up a circuit according to this procedure that they have been given. So we already set up a circuit according to the lab sheet as well. So from the table 1, the resistance kept the same and the voltage will increase, and this current intensity measured value we got it from the circuit that we have been used from the simulation, and this current intensity theoretical we got using this formula. So according to the Ohm's law, when the voltage increases, the current intensity measured value increases as well. So for this current intensity theoretical, I've been used this formula where I equals to V over R. So 3 voltage, 200 ohm, and I got the current intensity theoretical value as 15 milliampere. So which is similar with the intensity measured value and the theoretical measured value. So I have been repeated the same step for each of the value. For the 6 voltage, we got 30 milliampere, 9 voltage, 45 milliampere, and 12, we got 60 milliampere. For the second table, where the voltage remains the same, the resistance increases. So according to the Ohm's law as well, whenever the resistance increases, the current decreases, where the graph will be like inversely proportional. So for the current intensity theoretical value, we have been used the formula I equals to V over R. So we just insert the value 5 voltage over 68 ohm. We got 73.529 milliampere, which is similar to the value that we got from the simulation. For the 100 ohm, we got 50 milliampere. 1000, we got 5 milliampere. 4,700 ohm, we got 1.0638 milliampere, and for 10,000 ohm, we got 0.5 milliampere. So for the questions and discussion, Tommy will proceed with it.
Okay, so greetings, very good day to you. Okay, I'm Tommy Lee. So here comes the question and discussion part where I will explain, okay, from our data table. Okay, we have examined what happened to the current and voltage when it is doubled, tripled, and quadrupled. Okay, as we know that in table 1, the voltage is directly proportional to the current, and I will show it why is it so. Okay, so the voltage, it starts with 3 volts, and what we've measured in our simulation, we get 15 milliampere. So when the voltage is doubled, the current intensity measured will be 30, which is shown here. Okay, so when we double it, it becomes 6 volt, and we get 30 milliampere. When we triple it, which is 9 volt, and we get 45 milliampere. And when we quadruple it, which is times 4, we get 12 volts and 60 milliampere. So as the voltage increases, the current intensity will be directly proportional as well. Okay. So based on our table 1, okay, the relationship between voltage and current as described in Ohm's law, okay, the equation that we have derived from the original formula, which is V equals I times R. So we get I equal V over R. So it tells us that the current flowing through a circuit is directly proportional to the voltage. Okay, so in other words, if the voltage increases, the current will increase as well. Okay, and question number 3 is based on our table 2. So what we have examined, so the resistance is inversely proportional to the current, and I will show you why is it so. Okay, so what we have in constant here is the voltage. So all voltage here are 5 volts. Okay, so resistance is the manipulative variable, and the measured current intensity is the responding variable. So as you can see, when we increase the resistance from 68 ohms, 100 ohms, 1000 ohms, 4700 ohms, and until 10,000 ohms, the current intensity measured will be decreasing proportionally. Okay, it is inversely proportional to the resistance. Okay, so we can say that when the resistance is doubled, the current becomes half of the previous value, and when the resistance is increased by tenfold, the current decreases by tenfold as well. Okay, so based on our table 2, okay, the relationship between resistance and current as described in Ohm's law, using the equation that we have derived, I equals to V over R, it tells us that the current flowing through a circuit is inversely proportional to the resistance, and if the resistance increases, the current will decrease as well. Okay, moving on to question 5. Okay, so we have plotted a graph on Microsoft Excel, okay, of voltage versus current intensity. Alright, so for both the simulation and theoretical results in our table 1, so this is what our result shows, that as the voltage increases, the current intensity will increase as well. So the line shows that it is directly proportional. Okay, so as for question 6, the Excel graph, I will hand over to Yamuna to give us an explanation on our findings.
Yeah. So for the question number 6, we use the Microsoft Excel to plot a graph of current versus resistance. So this is the resistance on the x-axis and the current intensity on the y-axis, where the current intensity measured value and the theoretical value is similar. So as according to the Ohm's law, as we know, as the resistance increases, the current intensity decreases as well. So where we can simplify and explain it in a way where the graph will be inversely proportional. So this is how the graph will be for current intensity versus resistance. Okay. So next I'll be showing on the simulation. So I'll give two examples according to the table that we have been done. So over here, I will change the value for the voltage. Okay, 6, and then the R1 remains the same, 200 ohm, and I will switch on the switch and run this to show up the value of the current. So we got 30 milliampere, which is similar to the table that we have gotten. So okay, next 9 volt. Resistor remains the same. I switch on the switch and run the simulation, where we got the current value 45 milliampere, which is same as the table as well. So according to the table 2, Tommy will present another 2 examples for it.
Okay, now sir, so I will be explaining the examples for our table 2 here. Okay, so as you can see now, R is the manipulative variable, and what we're trying to respond right now is to the current intensity measured inside the simulation here. So what we keep in constant right now here is the voltage, which is all 5 volts. Okay, so right now I will change the resistance to 68 ohms right now. Alright, I'm closing the switch, so I will run the simulation. So right now it shows that the ammeter shows that it's 73.529 milliampere, okay, which is what we recorded, and it is similar to the one we have calculated in theory, okay, which we used our derived formula from V equal I times R, so which is now I equals to V over R, so we get the same value as well. Okay, right now, so I will choose another example, which is 4700 ohms. Okay, let me stop the simulation. Okay, 4700 ohms. Okay, I will run the simulation. Now the ammeter is showing 1.0638 milliampere, okay, which is exactly what we have recorded, and it is similar to the one we have calculated in theory. Okay, so this proves that in our graph here, alright, that the current intensity is inversely proportional to the resistance. So this proves that Ohm's law has been implemented in this experiment. So I think that's all for now, and I thank you.